Okay, so here's our first example here. Now, you are given the mass and the velocity of both before the collision. And what we want to figure out is the velocity of the two together after the collision, right? So like a hit and stick collision. So the nice thing here is you already have the momentum calculated out for you. So here what you have is before the collision, all of the momentum that I'm going to have is just this 20,000 kilogram meters per second that is provided by the car. And the reason for that is the truck is stationary. The truck isn't moving, so it has zero momentum. Now, what's going to happen is I'm going to take that as the momentum before the collision. So I know that the whole momentum before the collision is just this 20,000 kilogram meters per second. Now, just using our P equals mass times volume or times velocity, formula P equals m times v, I'm going to rearrange that. I know the mass, right? Now the mass is going to be 4,000 kilograms because I'm going to add the two together because now it's a more massive object. And then I'm going to figure out the velocity from there. So what I'm going to do here is I've got my 20,000 from the momentum of like before the collision, and I'm going to divide that by the new mass, which is, here I'm just going to put it in brackets here, 1,000 plus the 3,000 that I am given. So I don't know if you can, it's hard to read here, but I've got, 20,000 divided by those two masses added together, okay? And I get 5, so that's 5 meters per second is their final velocity, okay? Now note that this is going to be in the same direction as the car was traveling, okay? So I have my stationary truck, I've got my car that comes in, hits it, now they're joined together and they're going to move a lot slower now because they're a more massive object, but the momentum is the same.